Here's a problem where we will be using our TI-83 calculators. It's been stated that about 41% of adult workers have a high school diploma but don't pursue further education. If 20 adult workers are randomly selected, find the probability that at most 12 of them have a high school diploma but do not pursue any further education. How many adult workers do you expect to have a high school diploma but not pursue any further education? So in this scenario, we are going to let X equal the number of workers who have a high school diploma but don't pursue any further education. So that means that X is from 0 to 20, and let's fill out these values. So N, there's 20 total adult workers, so N is 20. The probability of success in this case is 41%, so 0.41. Then to get Q, we have to do 1 minus P, which equals 1 minus 0.41, which equals 0.59, so 59%. Then X is a random variable with a binomial distribution of, we put our N value here, and then we put our probability of success. Then the last thing we want to do is we want to find the probability of what they ask. How many adult workers do you expect to have a high school diploma but not pursue any further education? And it's find the probability that at most 12 of them have a high school diploma. So at most means that X is less than or equal to 12. So let's go ahead and use our calculator. Now let's take a look at how we put this into the calculator. I have put the directions up here. You're going to hit second, and then distribution right here is above the variable button. Then you're going to go down until you find binom CDF. We hit enter. We put our N value, which is 20, comma, our P value, which is 0.41, comma, and then our number 12, because we want at most 12. I'm going to close my parentheses and hit enter. So the probability and the solution to this is 0.9737. So there's a probability of 97% that at most 12 of the workers have a high school diploma but do not pursue any further education. Here's another example. John comes to class totally unprepared for a 20-question true-false quiz. So he guesses randomly. We're going to let X equal the number of questions that John guesses correctly. So guessing correctly is a success. And then X takes on the values from 0 to 20 because there's 20 questions in the true-false quiz. So N is the number of trials, which in this case is 20. P is the probability of success. So because this is a true-false quiz, there's a 50% chance that he's going to guess correctly. So let's put 0.50, 50% chance. So 1 out of 2 for a true-false. Next is X is a random variable with a binomial distribution, and we put here our N value, and then we put here P value. Now, if they want us to calculate the mean or the mu, all we have to do is N times P. So 20 times 0.5, which in this case is 10, and that's an average of 10 questions. Okay, the variance is just N times P times Q, so 20 times 0.5. Q is just 1 minus 0.5, which is the same, 0.5. When you multiply all that all together, you get an answer of 5. So the variance is 5. And then the standard deviation is the square root of the variance. So it is simply the square root of 5, which is approximately 2.24 questions. If they ask us to find the probability that John guesses 7 questions correctly, so this is the same thing as saying the probability of x equals 7. So let's go ahead and put this into the calculator. So we need to go back to second distribution. For this one, and you can look in your textbook, it tells you which ones to use for which examples. We do binomial PDF, and we are going to put in our n value of 20, comma, our p-value of 0.5, comma, and then 7 questions is what we are guessing. Close your parentheses, hit enter. So the probability, that was, if you didn't catch it, is 0.0739, so which is 7.39%. So the probability that John guesses exactly 7 questions correctly is 7.39%. Now let's find the probability that John guesses more than 7 correctly. So we would write this the probability of x greater than 7. So for this one, let's clear this out. We are going to do 1 minus and then do the calculation. Again, these directions are in your textbook as well. So second distribution, we're going to go down to that binom PDF. Enter 20, 0.5, 7, close parentheses, and we get an answer 0.9260, round up to 61. So 92.61% probability that he would guess more than 7 questions correctly. Now let's find the probability that John guesses 6 or 7 questions correctly. And so the way that we do that is we are simply finding the probability of x equal to 6 plus the probability of x equals 7. And you can put this in your calculator all at once, and I'll show you how. So we are going to hit second distribution, binom PDF, and 20, 0.5, 6, close parentheses, plus, and then we'll go back and do it for the probability that it equals 7. All right, so there's our equation. We're adding these two. We hit enter, and we get 0.11089, so that would be 11.09% chance, the probability that John guesses 6 or 7 questions correctly.